This chapter, sound, we will see the important questions of the sound chapter. We'll do some MCQs followed by short answers and long answers. First question, a list of mediums given below. In which of these mediums sound can travel? Sound can travel in a solid medium. So wood, which is a solid medium. Sound can travel in a liquid medium, which is given as water. Sound can travel in air medium, but sound cannot travel in a vacuum. So the option is 1, 2 and 3. Option is B. Next. Let us do the second question. The loudness of sound depends upon. Loudness is a characteristic that depends upon the amplitude of the sound. So loudness is measured by decibels. So loudness, the formula is loudness is directly proportional to amplitude square. If amplitude is 2, then loudness is 2 square. That would be 4 decibels. So the answer is amplitude. It's amplitude. Next. Which of these following statements are correct? Sound is produced by vibrations. Yes, always a vibrating object produces sound. Sound requires a medium for propagation. Very true. The medium can be solid, liquid or air. Light and sound both require a medium for propagation. Actually, light here, it travels in vacuum also. What is vacuum? Vacuum, when you remove the air from a given place, it's called as vacuum. Light can travel in vacuum also. Now, sound travels slower than light. True. So, the option is 1, 2 and 4. So, D is the option. An object is vibrating at 50 Hertz. What is its time period? So, when you see the Hertz, we know the unit of frequency is Hertz. So, what is frequency? Frequency is the number of oscillations per second is called as frequency. The unit is Hertz. The unit is Hertz and the symbol is capital H and Z. So, frequency is equal to number of oscillations per second. So, 1 Hertz will be equal to 1 oscillation per second. So, if an object is vibrating at 50 Hertz, what is the relation between the time period and the frequency? The time period frequency is equal to 1 by T, or we can say T is equal to 1 by F, frequency. Therefore, T is equal to 1 over 50. So, when I divide 1 by 50, 1 is a small number, I keep a, place a 0, for that I keep a dot. So, till 10 doesn't go in 50 table, I add 1 more 0. So, when I add 2 zeros, I keep a 1 dot and 1 0, then it is 2 times 100 0. So, T is equal to 0.02 seconds. This is the answer for time period. That is, option is A. Fifth one. In order to reduce the loudness of a sound, we have to. So, we know that always this loudness is a characteristics related to amplitude. So, higher the amplitude, more loud will be the sound. Less the amplitude, the sound will be feeble. So, we have to decrease its amplitude of vibration of the sound. The option is C. Loudness of sound is measured in the units of, as I said, decibel. The loudness of sound is determined always by the amplitude of vibration. It's always a characteristics of amplitude. 1 Hertz is equal to 1 oscillation per second. Oscillation is also called as vibration. Both share the same meaning. So, it should be 1 vibration per second. So, now if it is 1 oscillation, 1 hertz is equal to 1 oscillation per second, or 1 vibration per second. But when you look at here, the option is everything is minute. So we know 1 minute is equal to 60 seconds. Therefore, you have to multiply this into 10, so it would be 60 vibrations per minute, because we know 1 second is 60 seconds makes 1 minute. So the option is C, 60 vibrations per minute, because 60 seconds is equal to 1 minute. Then pitch of sound is determined. Actually, pitch is a characteristics of frequency. It's a characteristics of frequency. So if you want to denote the frequency through a sound wave, so this is here, this is, let us consider these two graphs. So when you look at both the waves, you could see that here the frequency is low. Here the frequency is high, meaning you have to see the to and fro motion, the vibration. One vibration, you see, you can see the one vibration. Here the waves are less. Here the waves are closer. Here the waves are far. So closer the waves, higher is the frequency. So pitch, or we will call as the shrillness, they are the characteristics of frequency. So higher the frequency, high will be the pitch. Lower the frequency of vibration, low will be the pitch. So now pitch of sound is determined by its a characteristics of frequency. So if you take drum, a drum, it has more amplitude or frequency. They will give you two options, more amplitude or high frequency. A drum is loudness, so it has only amplitude, and it has more amplitude and less frequency or low frequency. When you whistle, when you play the whistle, when you blow the whistle, it has more frequency and low amplitude, because the sound will be, pitch will be high with a shrillness sound. The 10th question. Ultrasound has frequency of vibrations. Usually, vibrations, when we talk about the vibrations, the frequency with which we can detect is the frequency with which a human ear can detect is, it is equal to 20 hertz to short answers now. Lightning can be seen the moment it occurs. Paheli absorbs lighting in her area. She hears sound 5 seconds after the lightning. How far is she from the place where lightning occurs? When they say how far, they are asking the distance. We know the formula, speed is equal to distance over time. Therefore, distance is equal to speed into time. Speed, it is given as speed of sound as 330 meter per second into time is 5 seconds. So when we multiply, the answer would be 5 3s are 1650. The distance, it is meters. Next question. Does any part of a body vibrate when we speak? Name the part. Sure, yes. One of the part of the body is going to vibrate, yes. Name the part. That part is called as the vocal cord or the larynx. So when we speak, this vocal cord is going to vibrate. How? So there are actually, we have two vocal cords on either side of the vox box. We have two vocal cords. This two vocal cords are either side of the voice box or the larynx. So across the larynx, or it's also called as the voice box, this vocal cord will vibrate. So between the vocal cords we have a narrow stretch. So between the vocal cords we have a narrow slit. You see, this is the vocal cord. This is the vocal cord. We have a narrow slit here. So when the air is entering the narrow slit, vibrations are produced or sound is produced. Vibrations are generated, producing sound. So when air enters the slit, when the air enters the slit, it gives rise to vibration. Vocal cords vibrate. When we know that any vibrating object produces sound. So when vocal cords vibrate, they produce sound. So the slit, through the slit, air enters, vocal cords vibrate, then which produces the sound. So if the slit, it can be narrow, or it can be, or we will talk about the cord. The cord can be tight or loose. So if the cord is tight, then the voice, it will be very thick. So when they are tight and loose, the voice will be different. When they are tight and thick, the voice will be different. So the vocal cords, when they are tight and loose, the voice will produced voice will be different. Then if the vocal cords are tight and thin, the produced voice will be different. So which is making the vocal cord tight and loose or tight and thin? The muscles attached to the vocal cord. Muscles attached to vocal cord. That makes the vocal cord thick and loose or thick and thin. Next question. Booch Ho saw a cracker burst at night at a distance from his house. He heard the sound of the cracker a little later after seeing the cracker burst. Give reason for delay in hearing the sound. We know that speed of sound is slower than the speed of light, or we can say speed of light is faster than speed of sound. That is the reason we first see the light, that is crackers, when they burst they give out light. We see the light, then followed by the sound. So when we hear a sound, does any part of the body vibrate? This is when we speak. That question was when we speak. Here when we hear a sound. Sure, when we hear a sound, our eardrum vibrates. So eardrum vibrates. So when eardrum vibrates, we know a vibrating object produces a sound. So what is a eardrum? Eardrum is nothing but it's like a stretched rubber sheet. Stretched rubber sheet. So from the eardrum, the vibrations sent to the inner ear. The vibrations sent to inner ear. From the inner ear, the signal goes to the brain. The signal goes to the brain. So here which part is going to vibrate? The eardrum, which will vibrate and produces the sound. Name two musical instruments which produce sound by vibrating strings, veena and sitar. Next. A simple pendulum makes 10 oscillations in 20 seconds. What is the time period and frequency of its oscillation? So we know frequency is the number of oscillations per second. So what is time period? Time period is equal to 1 by f, and frequency is equal to number of oscillations per second. But here they have given it for 20 seconds. So 20 seconds gives you 10 oscillations. For 1 second, that would be x. So x is equal to, and tx is equal to 10, x is equal to 1 over 2. So it is 1 second, you have 1/2 a oscillation or 0.5 oscillations. So now we have to frequency, we found the frequency. So frequency is equal to 0.5 hertz. So time period will be equal to 1 by 0.5. That would be, remove the decimal point by multiplying into 10, both the numerator and the denominator. That would be 10 over 5. That t will be equal to 2 seconds. So next question. We have learned that vibration is necessary for producing sound. Explain why the sound produced by every vibrating body cannot be heard by us. Because human frequency is between the range 20 hertz to 20,000 hertz. So we can only hear the frequencies between this range. So we cannot hear a frequency less than 20 hertz and greater than 20,000 hertz. We cannot hear the frequency. We can't hear frequency when they are this range. That is the reason we don't hear all the frequencies. Then next question. Suppose a stick is struck against a frying pan in vacuum. Will the frying pan vibrate? Will we be able to hear the sound? Explain. When the stick is struck against a frying pan in vacuum, the frying pan will vibrate, because we are hitting the stick with the the frying pan with the stick. It will vibrate. But will the frying pan vibrate? Yes. Will be able to hear the sound because it is vacuum. Sound do not travel, or sound needs a medium. So what happens? Sound is not, we don't hear the sound because sound doesn't travel. That vibrations that produces a sound cannot travel because it is a vacuum. So we will not be able to hear the sound of vibration because sound needs a medium, or sound cannot travel in vacuum. Next, two astronauts are floating close to each other in space. Can they talk to each other without using any special device? Actually, in space, there is no medium. In space, we have only vacuum. So we know that sound cannot travel in vacuum. So we cannot, without using a special device, the two astronauts cannot speak. So list 3 sources of noise pollution in your locality. So inside our locality, it will be vehicle honking. Then it could be bursting of crackers. If it has an industrial place, the sirens from the industry. So then we will talk about what is a noise and what is a musical sound. When unpleasant sounds are called noise. Unpleasant sound is called as a noise. So what is a musical sound then? Which is pleasing to the ears.